So what I want to do today is talk to you about how the Financial Times makes use of graph databases. And in fact, it's quite interesting from my personal perspective because just over a year ago, a little less than a year ago, not long after I joined the Financial Times, they actually changed their tagline. So what they changed it to was make the right connections, which is really about what graphs are. It's about making the right connections between the things that are in your data. But we're getting a bit ahead of ourselves. And so if the clicker's going to go the right way, no, that way. The Financial Times is actually quite an old newspaper. Chap from IBM was talking about IBM being around for 105 years. The Financial Times was actually first published in 1888. But it wasn't called the Financial Times then. It took it a few months to realize that it picked the wrong name. The first name was the London Financial Guide. And then a few months later, it changed its name to the Financial Times. And it started off being printed on white paper. But I think most people know the Financial Times as being the pink paper newspaper. Yeah? So it wasn't until 5 years later that actually they changed to printing on pink paper. Some people say it was to differentiate itself from a similar named newspaper of the time. Other people think it was because the paper was cheaper. I'm not sure which. Not going to make any comment. So the Financial Times has been around a long time and has seen a lot of things that are changing both in the financial markets but also in the world of newspapers. And in fact, around 2010, which is when this newspaper is taken from, sadly BP were cited for safety lapses in the North Sea. None of that kind of stuff happens anymore, does it? But in 2010, we started noticing quite a change happening in the industry, and that change was the sort of disappearance of a lot of people reading the newspaper in the physical form. So how many people here go out and buy a newspaper on a regular basis to read? So there's maybe a handful. I'm kind of counting maybe less than a dozen people, somewhere between half a dozen and a dozen. Which doesn't really surprise me because in 2010 we actually noticed that our sales of printed newspapers were starting to decline, and what was happening was people were starting to consume the news through the websites. In fact, the Financial Times was one of the early newspapers who introduced the concept of a paywall for newspaper articles, because what we wanted to do was kind of encourage people to come and read our stuff, but at the same time we had to make sure that we had enough funds to pay for the journalism that we were using and the articles that they were producing. So we introduced a paywall so that you could read a certain amount of content for free, but certain content, certain premium content, or after a certain number of articles, you might have to start paying for it, and so the paywall came along. Then a few years later, probably fueled a lot by our HTML5 app in around 2012, the Financial Times actually started noticing that the revenue it was getting from its digital subscriptions was coming up to the level of the revenue that it was getting from its paper subscriptions. So a real sea change was happening, because until then we were making loads of money from, well, not necessarily loads of money, but we were making the majority of the money from the printed editions. And now what we were seeing with the HTML5 app was actually people would prefer to consume news through websites and through HTML5 apps. And one of the great things about the HTML5 app was that unlike a standard website, you could actually download articles and read them offline. So you could kind of like synchronize and while you sat on the tube or on the BART over here, you could actually read your articles, and it didn't matter whether you had a Wi-Fi connection or not, and not everywhere was Wi-Fi enabled in 2012. And obviously, when you go to a digital first kind of platform, you can do different things. So we started producing things like videos, interactive graphics, and podcasts. And that website actually served us very well, or served the Financial Times very well for a number of years. However, it did come with some costs. One of the biggest costs that it came with was that it was this big monolithic application. It wasn't just monolithic as in one code base, but it was also monolithic because the code and the data was all very tightly coupled in the database. So basically the database represented the stuff that was being shown on the website, on the front pages, which actually made it quite difficult for our HTML5 people to write an app, because it meant basically they had to kind of replicate the website. And also it meant that we weren't really able to kind of evolve into new areas, because we were limited by the platform which had been built. As good as well working it was ultimately going to be a limiting factor. So, in around 2013, 2014, this band, wrong direction, of brave developers decided it was time to rewrite things. And so they got together and they planned themselves this journey, and this journey would be to learn the lessons that we'd have in the past, so not to build a monolithic system, but also to try and build a system which would enable us to link our articles together because of the concepts and the types of things that we're writing about. So obviously the Financial Times writes a lot about organizations and people, and so what we wanted to be able to do was to be able to link different articles by the concepts that were being written around in them. So you could see a series of articles on particular companies or particular types of topics. And so it was decided that what we would do was, I say we, I wasn't actually there yet, as I'll show you in a minute, that what would happen was that we would produce a semantic linked data platform. It seemed like a fantastic idea at the time, because people like the BBC had been very successful in their linked data platform and had done things like the Olympics with it, and it all seemed wonderful. I mean, what could be better? You want linked data? Everyone talks about open data, and wasn't talking about linking data at that time, and the way to do that was through triple stores and graphs. And so off they headed towards the lofty peaks of semantic land. For my own part, life was a little bit different. Still not going to go the right way, is it? Yeah, there we go. So this is me a few years ago. I am a little bit different today, but it's actually not that old a photograph. It's about 2.5 years ago now the photograph was taken. For my own part, I was taking a break because I was training as a counsellor and also waiting for the arrival of my second son. So I was carefully biding my time and working as a voluntary counsellor until in 2015 it became time for me to find a new job. Yeah, you got it right. And I came across this, which was looking for a Java developer on a brand new publishing stack. Oh, okay, that sounds interesting. Greenfield development, working for the Financial Times. Previously, I'd been a freelancer and I had worked for Pearson on their API program, which was exposing their content through a series of APIs so that developers could repurpose it and use it. And what interested me particularly about this was APIs for content delivery. Yep, been doing that. Harnessing triple store capabilities for semantic enrichment in order to offer more flexible ways to ingest well, I won't leave you to read the rest of it. But triple stores had been something that had interested me quite a bit, because when I'd worked on the contract at Pearson, one of the things I'd wanted to do with our content was to actually be able to link it up better. And as I said, the most obvious way of doing that at the time was through a triple store. So I applied for the job. Had an interview. Turned out that I actually knew the person who was interviewing me, which is always quite handy. Makes life a bit easier. And accepted the position at the Financial Times, and we agreed a start date. I arrived. And when I arrived, it turned out that the project had reached a bit of a decision point. So when I arrived, I suddenly became aware that the senior management team were not particularly happy. And the reason they weren't particularly happy was that although there had been lots of work done on this semantic linked data platform, it hadn't really started to deliver the business value that they were expecting from it. There had been quite a few problems with the delivery of it. And in fact, to the point where people were going, well, actually, should we can this project? So we'd really reached this point in the program where it was at risk of failure, and therefore, actually, I wouldn't have a job. It was not a good position to be in. So we took a look at what we were trying to do and the things that we were trying to do it with. And when we looked at the kind of stuff that we were taking on our journey with us, it it became quite apparent that although we'd built a good collection of equipment to build our system with, actually part of the problem was that we weren't able to get there fast enough because we had a huge kit bag which we wanted to take with us. And so being able to move quickly and deliver was being hampered by some of the choices that had been made in the program. And in fact, it wasn't just about technology. It wasn't just about the fact that the product we were using wasn't actually doing what we wanted it to do, and there were problems with that. It was also because, to some, rather than just a kind of exploration and a journey to this end point of producing a business value, it became a bit of a religious experience. They were going off towards the holy grail of semantic technology. And an example of this would be that some of the people who were involved in modeling would kind of go on some kind of go in some kind of retreat almost. They would sort of conjure the appropriate owl schemas, and then they'd come back out from the darkness and present us with the truth. And so, as you can imagine, that was not a very good way of working, because it meant that as developers we were very disconnected from the models and the data models that we were trying to build, and as a result of which also it meant that we started to get blockages, so that when we wanted some modeling done, it meant we couldn't do any coding, so they had to wait for the models to catch up with the code. And then, as you all know, when you start coding, you find problems that you hadn't realized before, so you'd go back to there. So all these kind of problems. And actually, the fact that people were really slightly fanatical about the models and the semantic stuff that they were producing, it kind of really didn't help the project. And what they'd lost sight of was that we were trying to deliver business value, and that business value was to be able to link our content and concepts. Our business didn't ask us to build a semantic linked data platform. It asked us to connect our data together. That's not to say that there were loads of bad decisions. There were some very good decisions. Architecturally, one of the great decisions that was made was to use microservices. So these kind of reusable components, or sort of separate sets of components that you can build together bigger systems. Now, I'm assuming everyone here is building using microservices these days. Anyone? Actually, no, I won't be unfair. I will ask, is everyone building microservices? Yeah? Good. I was going to ask if everyone's building a monolith, but that does seem kind of a bit unfair to ask you to put your hand up for that. So what that meant was that we were able to explore different possibilities. So we started, as I said, with Java as our programming language, accessing a triple data store. And it so happened that we had someone in the program who was a bit of a Go fanatic. So that meant that maybe we could experiment and try a different language as well. And also as part of that, we were thinking, well, let's try an alternative data store to go with it. So rather than trying to use triple stores in Go or Java and graphs, let's see what happens, what combination of things hits our sweet spot for us. Now, there were some sort of cynical programmers on our team who were kind of unconvinced that we were going to change and fix things. And so the way that we addressed that was to actually do an experiment, or in sort of agile terms, we did a spike. And so we got together and we sat in a room and we did some coding. And what we found at the end of that week's worth of coding was the combination that worked best for us was Go and Neo4j. So we chose Neo4j because of its ease of use and the way that we could model our graphs easily. And we chose Go because it enabled us to write less code in order to do it. And I'll show you a little bit of the code in a minute. But really, I suppose what we actually chose was the Neoism driver. So is anyone here a Go programmer? 1, 2, 3. Very few Go programmers. Okay. So Neoism is a really nice library for Neo4j. Unfortunately, it doesn't yet support Bolt. I'm not sure if it's going to or not. So perhaps one thing we might be thinking of doing in EFT is trying out the new Bolt drivers for Go and see whether they kind of give us an advantage over the Neoism drivers. But we chose, part of the reason why we chose Neo4j was the modeling. So I talked about kind of the acolytes of semantic world who kind of went off and did their own modeling. What we found was that we could quite easily whiteboard these things. So here, for example, is a really simple model. It's a model of an organization which is called Apple. Not many people have heard of this organization. We have our own identifier for it, but our data that we hold about the organization Apple is not the sole source of information. We take it from other systems as well. And in fact, there is an LEI code associated with a lot of organizations, which is a code used to track financial transactions. And so we have a number of different things which identified our organization called Apple. Apple is a public company, which is a company, an organization, which is a concept in our system and is also a thing. So that's kind of a hierarchy of our nodes in our graph database, and come on to why we use things like a thing in a few moments. But this allows us to apply multiple labels so that we can actually refer to all concepts that we know in the system, and Apple being one of those concepts, or we can just look specifically for companies as well. Because one thing that's really nice about Neo4j is this ability to apply multiple labels, and then those indexes means that it's very fast or faster to look up by a label of company than it is to somehow look at everything and then try and figure out what it is that you're looking at. And let's face it, doing things like that around a whiteboard is a lot easier to understand than OWL, or actually as it should be called WOL, isn't it? Because it's web orthogonality. I'm not going to say it. But basically, the acronym's ran the wrong way. So this is a little bit of OWL. It's not actually part of our system, but as you can see, it's a load of XML for those people who haven't come across OWL before. And a lot of people spend a lot of time writing stuff, and you can do great modeling in it. But at the end of the day, it's not as easy to look at and to understand as a simple circle diagram like that. So as I said, one of the things we did was we started off very simple. We put all of our identifiers into our nodes. We soon realized that was a bit of a novice mistake to make. So we separated them out. And I'm sure that other people who have been in similar situations probably do the same thing themselves, in that you end up creating new nodes with different labels applied to them, which have relationships to the thing that you're looking at. So we can now look up all our different identifiers so that we can do concordance across our different systems much more easily. So we can look up things by different types of identifiers and figure out what other identifiers we may have in different systems. So we can concord our data more easily using this approach. So for the kind of 4 Go programmers in the room, sorry about this for everybody else, this is a little bit of the Go code. So as I said, everything in our system is a thing, and the reason for that is it allows us to define a common structure which we share amongst all our data types. For those who are not familiar with Go, the stuff on the right-hand side is how it's represented on the wire in a JSON format, which is not quite the same as the structures, but quite close. And one of the reasons we did this was that it means that we can use a technique called embedding, which means that effectively this is a kind of inheritance through composition that's going on. So we have a thing called a brand, which represents various brands that we write about. So the Financial Times is a brand, and we have sub-brands. Most brands have strap lines and all this kind of stuff, might have an image with it, have kind of relationships with parents and childs. But they have a thing. And the reason why we have a thing is that it means that the brand writer, or anything, in fact, that is writing one of our nodes, knows how to read and write things. And a thing means that you can have a connection to another thing. So in this particular case, a brand has a relationship with a parent and a set of children. It may have a relationship with something entirely different, like an organization. In fact, I'm quite surprised it's not got an organization in there. But that means that when we're writing, our microservices can, all of our microservices can write things, and when they're linking to other things, then they are able just to refer to them by the ID that they are. And then the specialized, the other microservices will know the details of those things. So a little bit of code. So one thing that we also decided to do was we decided we weren't going to go for the kind of classic pattern of using data transfer objects that we see in the Java world. So if I step back to that previous screen, this here is the description of our external interface, and the same external interface, the brand object, is returned directly from our query. So inside this query, we are actually building up an array of these brand objects which we can then send over the wire very easily. So we're kind of cutting out some of the boilerplate code that you might write in the Java world, where you go, well, I've got this object, I'm now going to copy a load of its properties over here, and then I'm going to try and persist it and then send it out. So it's kind of making things much lighter weight. Slight detail, but we'll skip over that for now. So that allowed us to build our new website. And in fact, the new website was fully launched just last week. It had been sort of brought in on a gradual basis. But that's not the only places where we use graphs in our content, because part of the website that we have is a section called MyFT. And MyFT is about being able to personalize the data for yourself. And so another use that we have for a different database, a different Neo4j instance, is in recommendations. So what we're doing here is we're relying on collaborative filtering, which means that if I'm following a load of topics, we also have a profile of what other topics people are following. And so I say, well, if I'm interested, actually this came up because I'm interested in cybersecurity, is one of the things I follow. And so it's looking at the topic cybersecurity, which I'm following, and saying what other things do other people follow who are also following cybersecurity. And it would appear that terrorism is one of the things that is followed by people who follow cybersecurity. So it's suggesting to me that actually I might be interested in reading about terrorism because I happen to be reading about cybersecurity. We also use it as well in terms of recommendations in order to surface things that are popular, so the kind of trending topics. So this obviously changes on a regular basis, but this is more about the kind of topics that people in general are reading, not the kind of topics that people like me might like to read. We also have used Neo4j for some more experiments. I'm going to risk a live demonstration, so bear with me if it goes slightly wrong. We have this thing. Is anyone, obviously everyone's familiar with the Kevin Bacon, 6 degrees of Kevin Bacon, kind of how people are linked together. So this was codenamed the 6 degrees of Angela Merkel. Let's see if I can get that to show. Excellent. So what you can see is basically what we've got is a list of things that have been written about in the last 7 days. And if we pick on, for example, we're over here in the States, aren't we? So let's see if Hillary Clinton will come up. If not, I've got some backup slides. Hey, there we go. So here pops interview Hillary Clinton. And what you can see is recently we've written about Hillary Clinton, and as part of it we have mentioned some other people. So these are going to be more familiar to you, but at least I know Barack Obama. So what you can do is you can start exploring the links between Hillary Clinton, or the articles that are talking about Hillary Clinton, and the ones that were also talking about Barack Obama, by doing things like clicking on the links between them. And then if you want to, you can actually kind of start going, well, actually, that looks like an interesting article to read. I now need to pay. I should have been logged in, I should point out, but I've obviously closed my browser at some point. But essentially, when the demo works, when you click through, you obviously can read the articles about it. So this is about how you can actually start changing the way that you're telling stories, because we're very used to being fed article after article and not very used to kind of exploring the connections that we're interested in. So what we're trying to do with this is trying to change the way in which people can read about the news and kind of explore the topics that they want to. And in fact, you can kind of keep going on. You can go, well, actually, what's linked to Vladimir Putin? And you can start seeing, well, Vladimir Putin is, and oh, look, who's this chap over here? So you can start reading all these different stories. So you can kind of explore and navigate your way around the content within inside the FT without being forced down either some kind of editorial route or some kind of sequential route that we kind of decide to surface. This is about giving more power to our readers to read it. Let's see, this will come back up. But that's not to say that we've fixed all the problems that we thought we were going to fix. We've still got some things we're trying to navigate our way through. One of the things that puzzles me at the moment a little bit, and I don't know who else might be joining me in this slight puzzlement, and that's the world of microservices and graphs. Because what often when you read about microservices is that each one of these microservices is responsible for the persistence of its own data, which is great. It means you can change this and you can change the database underneath and it's all nicely isolated. The power of the graph is you connect your data together. So one of the things that I am currently working my way through is actually how we start doing things like this. So this is the MyFT database over here on the right-hand side, and it's involved understanding our users and the concepts that they're following. On the left-hand side, there is our content graph, which is talking about organizations and people and articles that we write. But if we actually add a bit of extra information that I talked about earlier, and that is that articles, in fact, talk about concepts, and in fact, actually, these graphs, when you start looking at them, a person in our system is a concept. So, actually, is an organization. And in fact, an organization could be an external organization which we know nothing about, or it could be an organization who happens to be one of our subscribers. So we obviously sell corporate licenses to banks and to lots of commercial things, and we write about them. So we've got two different databases, but yet we may have the same sets of data. So we could kind of maybe stick them in the same database, but actually what would be kind of nice was if we could start bringing them together into a single graph, which is kind of what was being talked about in today's keynote, which is this idea of building all of our data together into a 360 view of the system. Now, I don't know about anybody else, but one thing that does slightly concern me is that kind of reminds me of a very famous sci-fi film, when I see that globe picture spinning around. And the challenge I think that we have at the moment is how to build these big connected graph systems without actually building a system whereby we can't change our microservices in the way they store data without affecting all the other components in it. Because if you do that, then although you can highly scale your databases, you are kind of building some kind of Death Star, because that's where everything sits together. So this is where we are currently at. We still have our separate content stores, our separate user repository or information about our users. And probably what we're going to try as our first set of experiments next is, well, rather than trying to mash them together in one go, let's mash them together somewhere else. And that way we can learn about what happens when you start mashing these data sets together. Because that means that I can still go and evolve my MyFT service independently of my content system, but hopefully I can find a way of bringing them together to fit new use cases. In an ideal world, in my land of fluffy rabbits and unicorns, what I'd really like to do is actually have more of a kind of a galactic view than this single world view, and to be able to run distributed graph queries across a network of graph databases. I know I live in the world of fantasy a lot of the time, and this is not going to be coming anywhere soon near, but things like Facebook's GraphQL is one way that they're trying to address it. There are performance issues around that, but it would be lovely if we can get to the point, at some point in time, where we actually have a proper distributed graph database. So I live in hope of that. So we've kind of learned that what we've done at the FT changed a lot of things. We took a step back from a failing project, and we kind of looked at the technologies that we're using and how we might be able to change things. And that has meant that it's actually changed culturally quite a lot of the things we do. The teams are more empowered now. We make our own decisions. And as long as we're delivering business results, then people are quite happy to support us. So if you find yourself stuck in a project which is hitting its head against a brick wall, be prepared to throw stuff away. We rewrote 18 months worth of work in just over 3 months. It's possible to do these things and to turn around failing projects by being brave, being willing to dispose of what you've got, and trying something new. So that's about all I have to say. I suspect we don't have much time. No, we've done. I'd love to talk to people, but thank you very much.